They filed it before the press conference, before the public statement, before anyone outside a secured facility in Maryland was allowed to see the raw telemetry. The data from the closest approach to the sun in human history was locked into a pipeline of calibration, processing, and institutional review. It has been more than 6 months. The file is not empty. The scientists with access to it describe the findings as extraordinary. One peer-reviewed paper, published in March 2025, by researchers at the Johns Hopkins Applied Physics Laboratory, used a specific phrase to describe the solar wind acceleration mechanisms recorded during the approach. Not yet fully determined. 6 years, 22 orbits, the closest any machine has ever come to a star, and the answer to the question the mission was built to solve is still described in cautious, defensive academic language as not yet fully determined, because admitting the truth would mean admitting that our foundational models of astrophysics are broken. This is the transmission pale frequency recovered. If you are drawn to stories the public was not supposed to receive, subscribe now, because what was recorded inside the sun on December 24, 2024, is one of the most significant unreported events in the history of space exploration, and it is still being filed. The Parker Solar Probe launched on August 12, 2018, carrying a question that had embarrassed solar science for over 80 years. Why is the sun's corona hotter than its surface? The surface of the sun burns at 6,000 degrees Celsius. The atmosphere above it, the corona, burns at between 1 and 3 million degrees. By every known law of thermodynamics, this is impossible. Heat flows outward. The atmosphere should be cooler than the surface below it. The sun violates this law continuously, in every direction, at every moment. Nobody has ever fully explained why. The probe was built to fly into the corona itself, not orbit near it, not observe it from a distance, enter it, fly through it, record everything. 7 times closer to the sun than any previous spacecraft. A heat shield 4.5 inches thick, carbon composite, absorbing 1400 degrees Celsius on its sun-facing side while maintaining room temperature on the other side, where the instruments lived. 4.5 inches between the instruments and the surface of a star. The mission was designed to answer the question. 24 planned orbits, each one closer than the last. 7 years of approach. The answer was supposed to arrive with the data. The first anomaly appeared in 2019. Not a malfunction, not a hardware failure, something stranger. The probe's instruments began recording sudden, violent reversals in the direction of the solar wind's magnetic field. They appeared without warning. They lasted only seconds. They were happening at distances from the sun where the solar wind should have been smooth, predictable, governed by 50 years of established equations. Instead, the magnetic field was folding back on itself. The engineers called them switchbacks. The name was casual. The implications were not. Something near the sun, inside or near the corona, at the exact point where the solar wind is born, was violently disrupting the magnetic field structure in ways that propagated outward for millions of miles. A paper was published. NASA held a press conference. The word unprecedented was used. The abstract described the finding as ongoing research. Ongoing research is what institutions say when they expected an answer and found more questions instead. They said it was fine. In 2021, the probe crossed the Alphane critical surface, the boundary where the sun's atmosphere transitions into the solar wind. Below this line, the probe was inside the sun. The switchbacks were still there. The coronal heating problem remained unsolved. The temperatures inside the corona remained inexplicable. And in 2023, a finding buried in a supplementary data release, not a press conference, not a major announcement, revealed that the dust-free zone surrounding the sun was measurably smaller than any model had predicted. Smaller, which means the probe had entered an environment radically different from the one the models described. The very models used to project the spacecraft's survival, its safety margins, and its instrument tolerances for its final, most dangerous orbits. They said the spacecraft was healthy. They said the data was clean. They said they were looking forward to sharing the findings. December 18th, 2024, the probe began its 22nd perihelion approach, the closest pass the mission had been building toward for 6 years. At this proximity to the sun, communication was impossible, the solar interference too dense, the geometry too constraining. For 6 days, from December 18th to December 26th, there would be no contact. The probe was alone, 3.8 million miles from the photosphere, moving at 430,000 miles per hour, inside the corona, inside the atmosphere of a star, recording everything, transmitting nothing, completely alone, for 6 days, in the most hostile environment, in the solar system, on Earth. It was Christmas. The team at the Johns Hopkins Applied Physics Laboratory waited. They had verified the trajectory. They had confirmed the heat shield performance. They had run the models that had already been wrong. January 1st, 2025. The signal returned. 3 words. A status beacon. Spacecraft is healthy. Nothing else. No preliminary data. No readings from inside the corona. No announcement of what the probe had found at the closest approach in human history. Just spacecraft are healthy. The mission team released a statement. They said the data would be downloaded over the following weeks. They said they looked forward to sharing the findings. They said the mission was a triumph. It has been more than 6 months. The full dataset has not been publicly released. What has been released is carefully bound. The published datasets confirm the switchbacks are present at closer range than ever before, more frequent, more energetic, still unexplained. The coronal heating problem remains open. A March 2025 paper from the Johns Hopkins Applied Physics Laboratory concluded that the mechanisms driving solar wind acceleration remain, quote, not yet fully determined. Not yet fully determined. After 6 years, after 22 orbits, after the closest approach to a star in the history of human spaceflight, the answer is still not yet fully determined. They have not said what was found at closest approach. They have not said why the switchbacks exist. They have not explained why the corona is hot. Here is what the sun can do. In 1859, a coronal mass ejection struck Earth. Telegraph stations across 3 continents caught fire. Operators were thrown from their equipment by electrical shocks. The aurora was visible from Cuba, from Rome, from Hawaii. That was before the electrical grid, before satellites, before the global financial infrastructure that now runs on technology that can be permanently damaged by a geomagnetic storm of sufficient magnitude. In July 2012, a Carrington-scale coronal mass ejection passed through Earth's orbit. It missed Earth by 9 days. We did not know it was coming. We would not have had time to protect against it. The Parker Solar Probe was designed to give us that time. to understand the mechanisms that drive solar wind, that generate coronal mass ejections, that determine what the sun will do next. The probe flew into the sun. It recorded the most detailed measurements of the solar corona in history. The data is still being filed. If you are still receiving this transmission, if the weight of what has not been released feels real to you, subscribe to Pale Frequency, because this channel exists to receive what was never supposed to reach you. Dr. Eugene Parker published his solar wind theory in 1958. He was 29 years old. The scientific establishment told him it was wrong. An editor overruled the reviewers and published it anyway. Parker was right. The solar wind exists. It touches every planet. In the solar system, Parker was 89 when the probe that bore his name launched from Cape Canaveral. He watched it lift off. He died in 2022, before the probe reached the closest approach, before the December 2024 perihelion, before the data that is still being processed in Maryland. He spent 64 years building toward the question the probe was designed to answer. The answer is in a file he never saw. The Parker Solar Probe has already changed solar physics. The switchbacks have generated entirely new theoretical frameworks. The Alphane surface crossing confirmed predictions that were previously unverifiable. The dust-free zone measurements recalibrated models used by every subsequent mission planning to approach the inner solar system. These are not minor corrections. These are the kinds of revisions that precede a paradigm shifts, the moments when a field's foundational assumptions are exposed as incomplete. Solar physics is in that moment right now, and the data that will most directly define what comes next. The measurements from December 24th, 2024, the closest approach, is not yet public. There are two explanations for this delay. The first is the official one, that cleaning raw space data is a meticulous, months-long process of converting voltage into physics. The second, what the probe recorded, a closest approach, contradicts decades of established theory. It doesn't just challenge the models, it shatters them, and the gatekeepers of solar physics simply aren't ready to admit they were wrong. Both may be true simultaneously. Only one has been offered. The probe is still out there, at this moment, moving through the inner solar system on its next approach. The instruments still recording, the signal still transmitting, traveling at the speed of light across 93 million miles. The signal takes 8 minutes to arrive. By the time it reaches the receivers, it is 8 minutes old. The sun you see in the sky right now is 8 minutes old. What it is doing at this exact moment, what the probe is recording at this exact moment, you will not know for 8 minutes, and what was recorded inside it on December 24th, 2024, at 3.8 million miles from the photosphere, in 6 days of silence, in the data still being processed, in a secured facility in Maryland that may take considerably longer. They said the data would change everything. It may have already. The file exists. We are still waiting to read it. If you want to be here when the signal arrives, subscribe to Pale Frequency. This channel exists for one reason, to receive what was never supposed to reach you. Tell me in the comments, do you think the full data will ever be released? Or was it filed the moment it arrived? The transmission is still in transit. 8 minutes from the source, getting closer.